Alright guys, so I am gone, so I'm just going to do a quick video here going through the stuff we need to get through today, and then you'll have the rest of the period to work on the homework. I don't think you'll find that it's very difficult, so hopefully we can kind of just cruise through this and then turn you loose. So remember a while ago we talked about the definition of a function. The definition of a function is a relation for which every input has exactly one output, meaning that every x-coordinate can only go to one y-coordinate. And the way to test that was with the vertical line test. If I draw, oops, that's not vertical. If I draw a vertical line anywhere through my graph, it has to only touch the graph one time. So that would be a function. Over here's one that's not, because if I draw a vertical line, I'm touching twice, so it's not a function, right? Again, over here, this is a function because anywhere over here, it's only going to cross once. Anywhere over here, it's only going to cross once. It looks like right here on the y-axis, it might cross twice, but remember, an open dot means it's not actually touching right there. It comes right up to it, but doesn't touch 0. Closed dot means it does touch 0. So we approach 0 from over here. We hit 0 at this dot, but not at this one. And then as soon as we get off of 0, we pick it up over here. So that one only has one input for every output also, so that one is also a function. Would this be a function? 4x equals 8. Well, we got to get x by itself, so x would be 2, right? So that means that all the x values are 2's. Y values can be anything because there are no stipulations on y in the equation whatsoever. So we can make y -2, -1, 0, 1, 2, or really any 5 numbers you could possibly dream up. And then plot those points. X is 2, y is -2, x is 2, y is -1, 0, 1, 2. And we can see that it's going to be a vertical line. Right? So, is that a function? No. If I draw a vertical line through a vertical line, it's obviously going to touch it more than once. It fails the vertical line test. This is only one input right here, correct? Oh man, sorry. This is only one input. And it has a bunch of outputs. 2 goes to a whole bunch of different places, so it can't be a function. How about this one? 4 equals y plus 8. Let's get y by itself, so let's subtract 8 from both sides. So y is going to equal -4. So that means that every y value has to be a -4. There are no x's whatsoever, so we can choose what we want for that. Again, it could be any number that you want to. It doesn't have to be these 5. Now let's plot those points. -2, -4, -1, -4, 0, -4, 1, -4, 2, -4. This one's obviously a horizontal line. So is that a function? Well, if I draw my vertical lines anywhere, I'm only going to cross one time, right? So this is a function. These are 5 different inputs. They all go to the same output. That's okay. Remember, airplanes and airports, each airplane can only go to one airport, but you can have several airplanes going to the same airport. You just can't have one plane going to multiple airports. That would not be good. Okay, so those are definitions of a function. Now we're going to look at this thing. We call it function notation. Okay, these two equations right here mean exactly the same thing. There's no difference. You'll see that the only thing we can visually see different is this guy right here. This is what you're used to seeing, y equals 3x minus 8. We know that x is the inputs and that y is the outputs. X and y coordinates. So over here, x is still the inputs, but the outputs we refer to as f of x. We read this as f of x, not f times x or fx, f of x. The f represents the name of the function, and it can be any letter you want to. It doesn't have to be an f. We just tend to use f commonly. We will use functions where the name of it is something other than f, like p of x or w of x or h of x or g of x. It can be anything. It's just a way to refer to the function. The idea is that if we're looking at a situation where we have more than one function, we can refer to the functions by name instead of all having y's and being confusing. The functions actually have different names because of this letter right here. X tells you what the input is going to be. So again, obviously for many of them, x will be the input. But we could have input be anything. It could be p of q, where p is the name of the function and q would be the input. And then instead of x's up in the equation over here, you would see q's. So it really means nothing. It's just the variable that we're plugging stuff in for. There are several benefits to using function notation over just y equals. Um, let's see if I can list them here. One is that you know it has to be a function. Underline that because you know it's a function. If somebody used function notation, they're telling you this is a function, you don't need to check it. You can kind of just take it at its value that it's a function. You don't have to wonder, I wonder if this is going to pass the vertical line test or not. Okay. It also, like I mentioned before, gives the equation or the function a name. Gives the equation a name, something that you can refer to it as. It gives you another way to list ordered pairs. I'll show you that in a second. Another way to order pairs. If I gave you something like f of 3 equals 12, that's exactly the same as the ordered pair 3, 12. Sorry about the slant. I'm using a little tablet and it gets a little carried away. 3, 12, meaning plug in 3, 12 comes out. You can list it this way also. And so again, if we had multiple functions that we were talking about on the same graph and wanting to talk about several different ordered pairs for each function, doing it this way allows us to give you the ordered pair and the function that it's in. So that's kind of another bonus. And the last one is it gives us a way to ask questions, which I will show you here in just a second, without having to use words. Okay, so, and like I said, these two are exactly the same. The graphs of these two equations would be exactly the same. There is no mathematical difference between the two. This one is still a function, even though it doesn't have function notation. It still is a function. This one is just telling us it's a function by the notation. But they are both functions. They're both lines. They have the same slope. Everything about them is exactly the same. It's just that this one we're using function notation with. And that gives us the chance to ask questions. So here's another function, f of x equals 4x minus 7. And I'm asking you this question right here. And what that's saying is, essentially, if I plug in 2, what's going to come out? If 2 is the input, meaning when x equals 2, what does y equal? And I can do that without writing any of those words. I don't have to say, what is the value of y when x equals 2? I can just give you this thing. And the idea then is we would say, okay, well, f of 2 is equal to 4 times 2 minus 7. Everywhere we saw an x, we are now going to replace with a 2. Remember how I said this is the input and it tells you what your inputs are? This is your input and it tells you what your inputs are. So we know that f of 2 equals 4 times 2 minus 7. We're just going to keep bringing this down. We're not going to do anything to this. This is just a name. It's a title. 4 times 2 is 8 minus 7. So f of 2 is going to be equal to 1, meaning the ordered pair would be 2, 1. So the way you leave the answer would just be f of 2 equals 1. Okay. So let's do f of 5. So f of 5 is equal to 4 times 5, it's not an x anymore, minus 7. Right? So again, this just carries. We're just going to leave that there. It's just like y. 4 times 5 is 20 minus 7. So f of x is equal to 20 minus 7, or 13. So f of 5, oops, sorry, I wrote x, didn't I? F of 5. That takes some getting used to. F of 5 is equal to 13. And again, it's telling you what the ordered pair is. It's telling you that if you plug in a 5, you're going to get a 13. Okay, so take a second and try this one on your own. It's a yo-yo. You're on your own. Okay, so pause the video for a minute, try that one real quick, and then come back and see if you got the right answer. Okay, let's see if we got it. F of negative 1 is equal to 4 times, not x anymore, x is a negative 1 now, minus 7. So f of negative 1 is, 4 times negative 1 is a negative 4 minus 7. So f of negative 1 is equal to negative 11. Okay? And it's that simple. All you're doing, this is a question you've answered before. It's just asked in a different language almost. Function notation acts like a different language. The meaning of the question is exactly the same. The answer is going to be exactly the same. It's just that the language the question has written in has been changed just a little bit. So it's more specific. Okay, so up here is the same question I've asked you before. So I'll let you guys pause this and try this one. Here's a new function, f of t is equal to 2t minus 5. So here's an example of where this is not an x, it's a t, and all it means is that t is the input variable. It's the only difference. Go ahead and pause this for a second and try -5 real quick. If you think you know what the second question is asking, you can try that also. Okay, so we're going to do f of -5. So that's going to be 2 times -5 minus 5. So f of -5 is going to be equal to -10, because that's 2 times -5, minus 5. So f of -5 has to be -15. So the f of -5 is equal to -15, and that's your answer. Okay. Obviously, I need to see work there so I know that what you're doing is correct. If you just throw a number up here, maybe you just made a simple mistake where you said this was 7 or something silly. But if you get this wrong and I don't see the work, I can't do any partial credit. Now the second question is a little bit different. Instead of asking when I plug in -5, what do I get? I'm saying what do I have to plug in to get -3? Sorry, +3. If 3 is the output, what did I plug in? So I'm basically going to substitute 3 for f of t up here. So I'm going to say 3 is equal to 2t minus 5. I'm telling you what the output is. The output is 3. I'm going to swap it out. Now this is definitely a question you've answered before, right? We're just solving that. So we're going to add 5 to both sides. So 8 is equal to 2t, divide both sides by 2, and 4 is equal to t. So t is equal to 4. And again, we could rewrite that as f of 4 is equal to 3. When I plug a 4 in, I get a 3. So I can answer that question either direction, and that's what I meant by function notation giving us another way to ask questions. Is it gave us a whole new vocab or a whole new language that we can ask these kinds of questions in without having to do lengthy sentences or paragraphs. I can just throw this at you, and you know what it means, and you know what you need to do. Okay, so homework's going to have questions just like both of those on there. Homework is day 10, which is going to be page 125. It looks like there are about 9 questions or so. So go ahead and get that started now. You should have plenty of time left to be able to finish this without having to have any homework over the weekend. You're welcome. So have a great weekend, and I'll see you guys in a while.